All right, let's talk AI. You hear the term AI model thrown around all the time, right? But what does that even mean? It's literally the engine driving so much of the tech we use every single day. So today, we're going to pull back the curtain and really break it down.
So, here's the game plan. We're going to start with what a model even is, then we'll get into how it learns. We'll look at the different kinds of models, how we actually put them to the test, and then wrap up with why this stuff matters so much. Sound good? Let's jump in.
All right, first things first. To really get AI, you have to understand the biggest difference between it and, regular computer programs. It's all about moving beyond those rigid, fixed instructions. And that journey starts right here, with the model.
So what is it, really? At its core, an AI model is basically a mathematical brain that's built to learn. Don't think of it like a calculator that just follows orders. It's way more like a detective. You give it a massive pile of data, a mountain of clues, and its job is to sift through it all and find the hidden patterns, the connections that we might miss.
And this is the fundamental difference, the real game changer. Think about a normal computer program. It's totally rigid. A developer writes a set of rules, if this, then that, and it follows those rules forever. But an AI model, it's completely different. As it processes more and more information, it can actually tweak its own internal wiring, its own logic. It learns and gets smarter all by itself. Kind of cool, right? Okay, so we've established that these models can learn. But how? What does that process even look like? Well, it all happens during a crucial phase we call training.
Yeah, you can literally think of training as sending the AI model to school. So step one, you got to give it its textbooks, right? That's the data. Let's say we're building a spam filter. The data would be millions of emails, each one already labeled spam or not spam. Then you pick the teaching methods. These are the algorithms, basically the strategies the model will use to learn. And finally, the model just studies. It digs through all that data, analyzing everything and looking for connections to build its own understanding of what makes an email spammy.
And this point is so important. I can't stress this enough. There's a saying in AI, garbage in, garbage out. It's just like a student trying to learn from a textbook filled with mistakes. It's not going to work. An AI model is only as good as the data you feed it. If that data is messy, biased, or just plain wrong, the results you get back will be unreliable at best and, honestly, sometimes even dangerous.
All right, so it's also really important to get that AI model isn't some generic one-size-fits-all thing. Not at all. Think of it like a toolbox. You wouldn't use a hammer to saw a piece of wood, right? Same idea here. There are tons of different specialized models, and you have to pick the right tool for the job. And you can see that variety right here. For instance, you've got classification models. Their whole job is to categorize things, to put them in buckets. Is this email spam or not spam? Is this picture a cat or a dog? Then you have regression models. They don't sort, they predict a number. What's the price of this house going to be next year? And then you have the big guns, neural networks. These are inspired by the structure of the human brain, and we use them to solve really complex problems. So our model has finished school. It's been trained, but we can't just let it graduate and send it out into the world, right? Nope. First, it has to pass its final exams. This is the evaluation phase, and it's where we find out if the model actually learned anything.
See, it's pretty easy for a model to do well on problems it's already seen before. That's like giving a student the exact same questions on the final exam that were in the homework. They might have just memorized the answers without really understanding the concepts.
So the real test, the thing that separates just memorizing from actual learning, is this. What happens when you give the model a brand new problem, something it's never ever seen before? Can it figure it out?
And that leads us to probably the most important concept in all of this, generalization. This is the whole point. Generalization is how we measure a model's ability to perform well on new, unfamiliar data. It's proof that it didn't just memorize the training set, but that it truly learned the underlying patterns. That is the sign of a successful model.
Okay, so we've gone through the what and the how. We know what a model is and how it learns. But so what? Why does any of this actually matter to you? Well, let's talk about the impact this has on pretty much everything.
Because these models aren't just stuck in some research lab. They are everywhere. They're the engine inside the voice assistant on your phone. They're what powers the recommendation systems on Netflix and Amazon. They're even in hospitals, helping doctors spot diseases in medical scans way earlier than ever before. This stuff is real and it's here now.
And here's the bottom line. Understanding how these models work, how they're built, trained, and tested, isn't just for a handful of PhDs anymore. It's becoming an essential skill. If you're involved in technology in any way, shape, or form, you really need to get a handle on this entire process. It's foundational to building what comes next.
So we've kind of pulled back the curtain today and seen how these incredible tools are actually built. Which leaves us with a pretty massive question to think about, doesn't it? Now that we know how they're made, are we ready for what they'll make next? It's going to be interesting to see. Thanks for joining me.